Yes, good morning, good morning, good morning. I hope all are fine. Yes, good morning. Good morning. Yes, all fine. Okay. Yes. Now, in last class we have done few things. What was the last thing that we have written? Last thing that we have written. Yes, I am here only. Just okay. Just now came from the class. Okay. Meanwhile, you are also coming. So I'm here only. Yes. From the morning, actually, classes are there. So, okay. Ah, now I'm visual. Okay, quite tired. Yes. Sir, your last class after live not recorded in YouTube. I missed the live class. Okay, I will ask them. Okay, maybe they may not have. I think. Okay, recorded. Yes, maybe some problem. I think. Okay, I will ask them. Okay, they will check. Okay, if it is there. Yes. So, last class. Okay, I will ask them. Okay, they will see. They will check. So, what were the things we have done in the last class? What were the last? You can just tell me a few things. Then we'll start. Hmm. What were the last heading we have written? Effect on density. Okay, but I think we have not written a single question on the density. We completed density. Okay, density was completed. Yes, and okay. In density, one question: fractional change in density. Fractional question change. Okay, we have done. Okay. Yes. Okay. Write one more question. We can write one more. We can write on the density. Right then. Right, density of a material. Listen, this is the formula of density. Again, I'm writing here. Rho naught divided by 1 plus gamma delta theta is the formula of density. Whenever they're asking the formula, we'll use this relation. If they are asking, okay, suppose we have to solve the numerical. So for the numerical, we are going to write, we are going to use this rho naught 1 minus gamma delta theta. So for numerical, we have to use this thing. And for the, formula, somewhere they ask the formula, we are going to use this thing, okay? And for the last lecture, okay, I will ask them, okay, somewhere it might be there, I will check, okay, why it is not uploaded, okay, maybe some, okay. Now, so we can say in this one, rho equal to rho naught by 1 plus gamma delta theta, and this is the rho equal to rho naught 1 minus gamma delta theta for the numericals. Fractional change, if I say, then we can write fractional change is basically equal to, okay, your gamma delta theta, which is actually delta rho by rho naught. And if I say percentage change, then we can write percentage change is actually equal to gamma delta theta into 100. So these are the things we have done in the last class. Now, okay, right, density of a material, density of a material at 0 degrees Celsius, density of a material at 0 degrees Celsius is 10 gram per cc. 10 gram per cc. Density of a material at 10 degrees Celsius is, 0 degrees Celsius is 10 gram per cc. Clock question we'll do today, okay? We are going to do that question also. So at 0 degrees Celsius, it is the 10 gram per cc. And at 40 degrees Celsius, 9.96 gram per cc, okay? At 40 degrees Celsius, okay? 9.96 9.96, okay, 9.96 gram per cc. Now, so we can see here 10 gram per cc as well as 9.96 gram per cc. Find volume expansion coefficient. Find volume expansion coefficient. Okay. Find volume expansion coefficient means we need to find the gamma here, and for that we can use this formula that delta rho is actually equal to minus rho naught gamma delta theta. Density formula are same as volume. There is no major difference. Only that minus is coming, and minus only indicates that volume increasing and density decreasing. That's it, nothing much. So now we can write here in this one delta rho equal to minus rho naught gamma delta theta. I can write a change of density. So change will be always final minus initial. So we can say 9.96 minus 10. There is a 0.04 equal to, I can write minus. Okay, this will be also minus. Minus will be cancelled. Here we can write your 10 and gamma we have to find. And temperature, if you write, then 40 minus 0, that is the 40. Okay, so now we can write here in this pen that this is the minus cancel. So 4 into 10 power minus 2. And here I can write this is the 4 into 10 power 2 gamma. 4 will be cancelled. If you take this side 10 power 2, then we can write here gamma will be equal to 10 power minus 4 per degree Celsius. I hope this one is clear now. This thing is okay. Can we do the next question now? Next question. Okay, so in density, basically either they can ask fractional change or they can ask percentage change. So if they are asking percentage change as well as fractional change, we can do both, okay? As well as this question also we can do. So now we'll write next question on the clock, okay? Like pendulum is there. So clock based on the pendulum, what will be the changes in that we'll find, okay? So next heading you will write, okay? Effect on time period of pendulum, okay? Time period of pendulum. Effect on time period of pendulum, okay? Sir, I want physics from you and chemistry from Lalit sir. Already we are coming, yes? Already we are coming, okay? Lalit sir is also there, I am also there, okay? Okay, effect on time period of simple pendulum, okay? Yes, you know what is the time period of simple pendulum? You can say the time period of simple pendulum is, okay, T equal to 2 pi root L by G. Now, whatever this concept, it may not be very important in the thermal expansion. They have never asked this thing in the NEET examination from here. But it can be important in the oscillation chapter, okay? Yes, it can be important in the oscillation. So we can say ultimately we have to do this thing. Here I get T equal to 2 pi root L by G, okay? If temperature is changed, then G will not change. 2 pi will not change. So we get T proportional to your L power 1 by 2. Now there is one method, there is basically your change method or error method, very important method, okay? I can say here, this is the Y proportional to X power N. And now if Y proportional to X power N, and here I have to use, okay, change methods, we write like this: delta Y by Y is actually N delta X by X, okay? Delta Y by Y equal to N delta X by X means whatever the power is there, that power comes outside. So this method you have to keep in the mind. We are going to use in multiple chapters this thing. Whenever anything is written like this, in the proportional power comes outside, okay? So same thing I can write here. This is the L power 1 by 2. So we can say delta T divided by initial T naught will be equal to, here we get half delta L by L naught. But you know, delta L is basically how much? Delta L always, you know, there is the nothing but, sir, L naught alpha delta theta. So if I put here, okay, this value that alpha delta theta, okay, divided by 2, so we can say delta T finally becomes here in this one T naught alpha delta theta by 2. This is the formula that we need to remember, the T naught alpha delta theta by 2. Delta T is the change of time period, okay? Delta T is actually change in time period. We can write here delta T, okay, change in time period, okay? And we can say T naught is actually here, okay? T naught, if you say na, that the initial time period, T naught initial time period. Alpha we know, delta theta means temperature change we know. So this formula we have to keep in our mind. Okay, keep this thing in your mind, this formula. I'm saying again, may not be important here, but this can be asked anywhere. Okay, in the oscillation also this will be there. So if I say in one day, in one day, so how many seconds are there? Means in one day they will say how much changes will be there. So in one day, how many seconds are there? One day is basically equal to 24 hour. One day is always equal to 24 hour. So we can say first we'll convert into your minute into 60, again into seconds into 60. So we can write it will be your 86 400. So we can write here in this one, in one day T naught is basically 86 400. Okay, 86 400 seconds you have to keep this thing. Now they will ask theoretical question. If I say during summer, so you can say during summer what will happen? During summer, temperature will be more, and if temperature is more, then length will be more, and if length is more, then time period will be more, and if time period is more means earlier pendulum was taking 1 second to suppose complete this oscillation. Now it will take more time to complete oscillation, and if it's taking more time to complete oscillation, then it will be slow or fast. Slow or fast? Okay, theta more, length more, T more. Yes. If it is taking more time, then it will be slow or fast. Okay, you can, sir, if I am taking more time to do anything, it means I am slow. Like this we can remember. Okay, so you are slow, and when you are slow, then you will gain or lose. If you are slow, then you will gain or lose. We are going to will gain or lose if you are slow. If we are slow, we are going to lose. Okay, so we can say here, clock will lose time. If I say during winter, so we can say during winter time what will happen basically here. During winter, theta is actually less, so we can say length will be here, theta less, so length is less. Then we get it here, T will be your less. T is less means it will be your, it is taking lesser time, and taking lesser time is it is fast, and fast means it is going to gain here. Okay, so here it will gain. Okay, so these are the two theoretical points. Now we'll do the numerical. They can ask in the theoretical that if during winter what happens, during summer what happens. We can say during summer means temperature more, then it will be slow, and during winter we can say temperature will be less, so length will be less, so time period will be less, it will take lesser time, then we can say it will be fast as well as it will gain time. Okay, so we are going to write one question here. Yes, write question. Okay, ready? Ready for question? Okay. Dr. M's D. You can call to our official number and then you can ask whatever your queries are there. I will answer all the queries related to this thing only. Okay, whatever you want to ask related to this, I will ask 100%. Okay. Other things, we have our official number. You will call and you will get all the queries will be resolved. So we have questions here, right? Find how much time. Find how much time a clock will gain or lose. Find how much time a clock will gain or lose in one day. In 1 day. Okay, in 1 day. Okay, how much time it will gain or lose in 1 day if temperature rises by 40 degrees Celsius. If temperature rises by 40 degrees Celsius. If temperature rises by 40 degrees Celsius, then how much gain or loss will be there, we have to find. For this we are going to use this formula, delta T equal to, alpha will be always given in the question. Alpha is 2 into 10 power minus 5 degrees Celsius. Okay, 2 into 10 power minus 5 per degree Celsius. We have the formula delta T is nothing but the T naught alpha delta theta by 2. So I will just put this formula. T naught is actually here 86,400 in 1 day. And then we can say alpha here, there's the 2 into 10 power minus 5. Delta theta we got here 40 is the temperature difference, and then 2 will be cancelled here. So now we can see here 864 into 4, and how many 0 are there? Here 2 0 and here one more 0, so 3 0 and 10 power minus 5. So you can see this becomes 10 power minus 2. Okay, and finally if you multiply, then how much answer coming? Around 30, roughly I can say around 35 seconds. Okay, so this much loss, or 30, roughly you can say how much? 36.5. 36.5. Okay, roughly you can say the answer. It will lose or gain. It will lose or gain. You can multiply this. I am not writing any answer here. It will lose or gain. It will temperature more means it is going to lose this much time. Okay, this much time it will lose. You can multiply. Okay, this multiplication you can do. Right, next question. Make it fast. Then we are having next question. Right, ready for next question? Ready for next? Okay, then right. A clock based on pendulum is 5 seconds fast. A clock based on pendulum is 5 seconds fast at 10 degrees Celsius and 10 seconds slow at 40 degrees Celsius. A clock based on pendulum is 5 seconds fast at 10 and 10 seconds slow at 40. Okay, means we have one clock here. If I am going to 10 degrees Celsius, it becomes fast. If I am going to your 40 degrees Celsius, it becomes slow. Here fast, here slow, here fast, here slow. It means where it will be giving the correct timing. It will give correct time somewhere in the middle. Here it is fast, here it is slow. It means it will give correct time somewhere between 10 and 40. Okay, it will give correct time somewhere between 10 and 40. Anna? A clock, okay, 5 seconds fast at 10 and 10 seconds slow at 40. Find temperature. Find temperature at which it gives correct time. Find temperature at which it gives correct time. Okay, now what we can do here in this one, listen, that sir, here it is fast, here it is slow. It means it will be somewhere in the middle. The temperature at which it will give correct time, okay, we can write that one will be basically, okay, will be less than 40, okay, but it will be more than 10. More than 10, but it will be less than 40. Any problem in this one? It will be more than 10, but less than 40. I hope this point is clear. Because if this is clear, question is over. Yes. Now we can see when I am moving theta to 40, then here it becomes your 10 seconds slow. Okay, it becomes 10 seconds slow. But when I am going this side, then it becomes your 5 seconds fast. Okay, so I have to use this formula, which for the change we are having delta T equal to T naught alpha delta theta by 2. This is the formula. I can say here to here changes how much? Your 10 second. Delta T is 10 second and temperature difference will be 40 minus theta. If I say here, then we can say here to here, okay, here to here, change of time period is Change of time period is your 5 second. 5 second. Okay. And here we can write it will be how much your theta minus 10 will be the temperature difference. So now we can write here, first equation I will make from 5 equal to T naught alpha delta theta, we can write theta minus 10 divided by 2, equation number 1. And here I can write here 10 equal to T naught alpha, and then I can write 40 minus theta divided by 2, equation number 2. So these are the two equations that I have to use here, okay. One is basically 5, okay, here I'm writing 5 equal to, you can see 5 equal to T naught alpha, here theta minus 10, and here I have written 10 equal to T naught alpha 40 minus theta by 2. Now we'll divide, so we can say equation number 1 divided by 2, okay. So we can write here 5 by 10, if you divide then 1 by 2, T naught alpha cancelled, so we can say theta minus 10 divided by, we can write here 40 minus theta. Then we can do the cross and you have to get the answer, and then you can say, sir, this is nothing now for us. We can easily do this one. 40 minus theta equal to 2 theta minus 20, theta coming this side, so 3 theta equal to 40, 20 becomes your 60, so theta will be equal to how much, your 20 degrees Celsius. So this is the basically temperature at which it is giving the correct time, okay. Yes, clear? Can you solve the next question on this thing if it is clear? If you got this one, can you solve next question if I give you based on this? One more question. Will you try one more question on this concept? Means just for the practice. If you have problem, I will explain again this question. Yes. Ready for next? Ready for next one? Yes. Audio coming? Video coming? I think some network. Is everything coming? Because I'm not receiving your messages. Okay. Something was missing in the middle? Some interruption was there? In the middle, some interruption was there? Okay. This question is clear? Okay. Now, yes. So, net slow. I think somewhere in the some problem happened. Can we do next question? This is okay. Can we do next one? Okay. So I'm giving one question for you. You have to solve same pattern. Just I am changing the data. Okay. Data only change. Everything remains same. So right, a clock is 10 second fast. 10 second fast at 5 degrees Celsius and 5 second slow at 20 degrees Celsius. Okay, 10 second fast at 5 degrees Celsius and 5 second slow at 20 degrees Celsius. What will be answer? Make it fast. Same pattern, same thing. There is no change. Just data a little bit change. Now you have to tell the answer. What will be answer? Tell fast. Waiting for your answer. But do it fast. You're taking so much time. $15. First answer we got 15. What about next? $1.5. Again $1.5. What about others? Oh, mostly people are getting 15 now. Okay, good. 15 answer. I am not solving then. How to solve? Tell me fast. Okay. If all are getting answer 15, I am not going to solve. Yes. I am assuming 15 to be correct answer. Yes, because we can write here in this one directly. So 10 equal to, okay, 10 equal to, I can say T naught alpha, then I can write here theta minus 5 divided by 2, equation number 1. Then I get 5 equal to here T naught alpha, okay, and then I can say how much here 20 minus theta by 2, equation number 2. We will divide. So 2 by 1 equal to T naught alpha cancelled. So theta minus 5 divided by we get 20 minus theta. We can do the cross. So we will write here in this one. If you do the cross, then 40 minus, okay, 40 minus 2 theta equal to theta minus 5, okay. So you are getting the same answer as 15. All got correct answer. Right, next then, okay, next thing in this one. Right, effect on, next heading, effect on moment of inertia. Moment of inertia. Effect on moment of inertia. Okay, everyone knows moment of inertia is basically, okay, 2 by 5 mr square, 2 by 3 mr square. For the different okay bodies, moment of inertia will be different. But I can say one thing, that mass is constant. Whatever the 2 5 something will come, that will be also constant. So directly I can say I proportional to r square. Can I say this thing? I proportional to r square? Yes, I proportional to r square. So we will use the change method, delta I by I not equal to, I can say 2 delta r by r naught. Okay, power comes outside. Delta I by I naught equal to, we can write here in this one, 2 delta r by r naught. Yes. Now I can say delta r, you know, sir, delta r is always equal to r naught alpha delta theta. If delta r I put this one, r naught alpha delta theta, r naught cancelled, so it becomes how much? 2 alpha delta theta, and then we can say, so change of moment of inertia will be 2 I naught alpha delta theta. Now you have to remember this thing, 2 I naught alpha delta theta. If you forget also, then also we can derive this thing, 2 I naught alpha delta theta. Yes, 2 I naught alpha delta theta. Clear? Delta I, 2 I naught alpha delta theta. Any problem in this one? Finished? Okay, right, next thing, right here, effect on reading of scale. In last class, thermal stress and strain we have written, na? Thermal stress, that thing we have written. Yes, okay. So you will write effect on reading of scale. Effect on reading of scale. Effect on reading of scale, okay. Now, you know that, okay, length of 1 centimeter, okay, will not, okay, reading of scale will also change, okay. In the scale, if you know, like here, if a ruler is there, okay, this is suppose a ruler, okay. So you know that whenever we'll heat this one, okay, when this scale is heated, then this is the 1 centimeter from here to here, okay. So this 1 centimeter, if I say this space from here to here is the 1 centimeter, so this will remain as 1 centimeter always, or this will also change. If you heat, then this, okay, will increase, length will increase, and if you cool, then this will decrease. If you cool, then this will decrease. Clear? Okay, if you heat, then it will increase, and if you cool, then it will decrease. Like if I say here, this line is there, okay, if this is the line here, if I put one line, okay, and if I use, okay, take the scale measurement using the scale, okay, and suppose if I take here in this one, okay, like okay, suppose I got okay, this thing here, okay, suppose this is my 1 centimeter, okay, you can take this length is equal to how much? 1 centimeter, okay. Can I assume this one as 1 centimeter? This length I can assume as 1 centimeter, na? Like this pen is there, okay? So I can assume this one is 1 centimeter. So let's do the reading here. You can say, sir, 1, and then I can take 2, almost 2. Or for this also I can say, na, for this if I want to take, okay, this is the 1 centimeter, so you can say 1, and then this will be your 2, okay? So slightly more than 2, okay? Using this, I'm getting slightly more than 2. So reading is 2. But during okay, summertime, what will happen? During summertime, this will 1 centimeter will remain this, or it will expand. It will expand. And during summertime, it will expand now. So suppose it will not remain as this. It will expand. And suppose it expanded like this. And if expanded like this, then you can say, okay, now its reading will be how much? Now you can say its reading is equal to 1 division. So here reading will decrease or increase. Because if this will expand, then reading will be less. Now I'm getting here in this one, okay, 1, okay, 1, and then I'm getting here 2 times, okay. But if it expands, then I will get only 1. So length of, okay, if this division increases, then we can write reading will, whatever the reading will decrease, okay. Reading will, okay, reading I'm saying, okay, reading will decrease. Okay, if I say, suppose I am having your, okay, during winter time, what will happen? This will, okay, decrease, means this will contract, it will contract, so its length will decrease. Now I cannot, okay, means how to just, okay, how to decrease the length of this one. It is not possible to decrease the length of this one. I have another piece in which length is somewhat less, okay, like this is the one piece and this is the another piece here. And for this one, length is less. So I'm going to take, this is less, okay. So using this, if I take here readings, you can see using this one, what will happen basically? Readings will be somewhat, more readings will be there, okay. Or I can say without this, suppose this is my 1 centimeter, okay. So if this is the 1 centimeter, if I take a length of this one, then you can say, sir, 1 centimeter and then 1 centimeter. So 2 is the reading. During the summertime, what will happen? Length of the division will not be this. Length of the division will be more. So if length of the division becomes more, then I will get reading will be 1. Means reading is less. And during the winter time, length of the division will be, all the divisions will be closed. And when all the divisions are closed, then I will get, if this much space will be there, this will be the length of division. So I'll get here 1, 2, 3, 4. So reading will be more reading will be there. So what are the relation of the reading and temperature? Temperature more, reading. Temperature more, reading is. Temperature more, reading less. Okay, temperature more, reading less. Temperature less, reading more. Okay, so can I write this thing? I am going to write this one here, that temperature, okay, temperature more, scale reading less. And here I can say temperature less, scale reading more, okay. So temperature more, scale reading less, temperature less, scale reading more. And here I am taking scale is only expanding, okay. Right now, whatever the things I have told you, here I have not taken expansion of object. What is expanding? Only scale expanding, only scale expanding, object not expanding. And next part, okay, here I will tell in the next slide that if both are expanding, then what we'll do? If both are expanding, then what to do? We'll do in the next slide. But first of all, you remember temperature more, reading less, temperature less, reading more, okay. Write one question. Now, this is the question written here. Okay, just see. Scale gives measurement 20 centimeter at the 30 degrees Celsius. If it gives a correct measure reading at 0 degrees Celsius, then what will be the true value? Okay, then what will be true value we need to find. So we can say, sir, okay, 20 centimeter at 30 degree Celsius.